Carl Sterling here with topic 19. Find the magnitude and direction of a vector. I couldn't find that exact title anywhere, but I believe this is what I'm supposed to be showing you. Examples 61 through 64 on page 751. Find the magnitude to the nearest hundredth and the direction angle theta to the nearest tenth of a degree for each given vector. I'm going to try to show you examples 61 and 63, but I believe they will be different from these once we go into the program here. So we'll start off with example 61. We have negative 6i plus 14j. A is the coefficient for I, which is negative 6, and B is the coefficient for j, which is 14. And we're going to put them into the formula square root a squared plus b squared equals the magnitude. It's a pretty simple formula. Let me see if I can bring my math over here for us. Try this one here. Alright, we have a is negative 6, the b is 14. So we put that into the formula, negative 6 squared plus 14 squared. You just use your calculator. You could use one on your computer or wherever else you might have one. We're going to put in our 6 squared to get 36. We're going to put in our 14 squared to get 196. So we take our 36 plus our 196, we get 232. We're now looking for the square root of 232. I know in the past they would have either wanted that as the answer or they would have wanted you to factor out any perfect squares in there and work on that, but it's pretty simple here. All we have to do is pull out the calculator and put in 232 square root. 232 square root, we get 15.23. We'll round that to 15.2. Let me double check. Nope, they do want the hundredth, so 15.231 rounds to 15.23. 15.23. Nice. Alright, we're ready to find the direction of the angle theta. They want us to round to the nearest tenth with this one. A way to find angle theta is to use tangent of theta equals b over a. We remember our b is 14 and our a is negative 6, so that's 14 over 6 negative. We do want to think about this angle, and since it's just a single situation, we're going to assume that we're starting from the center, 0, 0, and we're going towards the point, or we're ending at the point negative 6 comma 14. This is our force going out in this direction. We found the magnitude already of 15.23. And now we want to determine the direction, so I'm going to put this 14 over 6 negative, and I'm going to find the tangent by doing the inverse tangent with the calculator. So I just put in 14 divided by 6 equals, I'm going to turn that negative, and I'm going to find the inverse tangent. I'm getting 66.8. Not sure if it really matters that it's negative or not. I just want to think here, 66 here is certainly not negative, and it's not in quadrant 2. Tangent is negative in quadrant 2, so I want to come up 66.8, or I want to do 180 degrees minus that value. Or I guess even with this case it's going to be adding 180 because it's already subtracting itself. Add 180. I get 113.19. That rounds to 113.2. So I'll just put that in here, 113.2. Great. Let's try another example. This is 6.6.63, or it's just the next question available. Find the magnitude to the nearest hundredth, direction to the nearest tenth. This one we have a little bit of basic algebra to work on, so I have that written up here. They're giving us 7i minus 3j, which is really a positive 7i and a negative 3j, minus, and it's in parentheses, so this is really negative 1 times 7i, which is negative 7i, -1 times -7, which is a positive 7j. I put this negative 7i right under the positive 7i. Those cancel out to make 0i. I put the positive 7j directly under the negative 3j. This is the same thing as 7 minus 3, so we get a positive 4j. Alright, here we have the math from that one. Our a is 0 and our b is 4. So it just gets put in the square root of 0 squared plus 4 squared. Of course, 0 squared is nothing, so it's just the square root of 4 squared, which of course is 4. Could have expanded that to 16 and brought it back to 4 as well. So that is our magnitude. We'll give that one a shot here. And that worked fine. Now we want to find theta. For this one, we're going to have to draw it out and just think about it. Alright, let's see here. Here it is all drawn out. We had a as 0, b as 4. That's the point 0, 4. And again, since it's just one point, we're assuming we're going from the origin towards that point. That would be a 90-degree angle going straight up. I had to do that because if I put tan of theta equals 4 over 0, I get undefined, which is another hint that it might be on the y-axis. So I'm just going with 90 degrees. No need to round for either value with that situation. Let's try one last problem together. This is similar to question 14 from the 6.6 homework. Took me a few tries to get this one down myself, but I finally have it down now. I really like to do this all in a calculator, but I'll share this one with you in this format. So take quite a bit of writing out, but again, you can just wrap it right off in the calculator, and it's really easy to do it that way. I always like to sketch out situations as I try to work on them, if it's at all possible, to make it as realistic for me as it can be. So I know I'm heading north and starting to travel west at 30 degrees. That means that I'm 60 degrees up from the x-axis. So really, I don't care about this 30 degrees anymore. I could scribble it out. All I care about is the 60 degrees going up, and that's going to be negative for cosine and positive for sine. I also had another boat traveling south and then west 55 degrees. That means that it's 35 degrees going down from the x-axis. That's going to be negative for sine and negative for cosine. We're going to have a lot of negatives in this situation. Again, I could care less about the 55 degrees or the 30 degrees anymore at this point, but the quadrants are important. The formula for magnitude is something like force times cosine theta plus force times sine theta. I don't really use this. I just start hacking away at the calculator, but I just thought I would show that here. We're just dealing with the first angle now, which was going up 60, and for cosine that's going to be negative. So of course cosine 60 is a half, but here it's going to be negative a half. X-axis is negative there, times the force. That force was 1610. You can see that up here. Don't really need the units at this time. To get that value, I'm just going to put in my calculator 1610 times negative 0.5. Normally I'd first put in cosine 60 equals, turn it negative, and then do times 1610, but in this case it was a nice smooth number. We don't have 1,000 decimal places like we normally would. Here with the sine, it was sine 60. Does it matter that it's radical 3 over 2? No, because this is not asking for anything with radicals or that form. They want everything rounded, so we just ignore that. We just put in sine 60 in the calculator, you get something like 0.86603. You do that times 1610. I did not do this times 1610. I did the full decimal just to be certain. I got about 1394.3009. Looks like I forgot to show this one, but we can show both of those here. We'll just pull out the calculator. I can even shrink it down here. I'm just looking at 60 cosine, and I got to make it negative, times 1610. That's negative 805, a nice whole number there. And with the other situation, it was just 60 sine times 1610. And that's where the 1,394 came from here. Now let's try the second angle. Here are those combined totals, negative 805 and negative 1023. This should have been a negative 1828. Of course, we're about to square it, so it really doesn't matter. It would matter if we were going to use cosine for the degree, but I like to use sine. My sine is accurate, negative 1390, or pardon me, positive 1394 and negative 716 is 677 point, and I even want an extra decimal here because I know I'm going to use this later and it has to be accurate, 0.33035. So I went ahead and squared the top. 1828 squared became 3,345,021, and I didn't even square it here. I had the exact value from the calculator, and I squared that exact value. Same thing here, I had the full version and I squared it. But I did use these abbreviations later. I added them together to get 3,803,798.1354. Went ahead and took the square root of that to get 1950.332. You're going to round that to the nearest hundredth to get 1950.33. So that will be our force, 1950.33. Great. Now it's time for the direction of the angle. This is actually really easy. Our final job to do here is to figure out the direction of the angle. I kept that sine value and I divided it by the magnitude that we have here. Sine value here is the combined sines, or at least that's what I call it. It was just your magnitude times the sine times the reference angle for both parts combined together. I do get 20.32 degrees, which is in quadrant 1. It's just that that doesn't really make sense that it would be in quadrant 1, right? Because the other forces were going outwards towards 3 and 2. If I were to try this with the cosine, remember our combined cosine value was about, let me get the calculator over here. Our combined cosine value was negative 1828. Remember, I forgot to make it negative 0.94006. I'm going to turn that negative. Oh, looks like I lost a number in there. That was 1828.94006 negative, and we want to divide that by the force over here, 1950.33. And we're going to take the inverse cosine. Of course, with the other one here, I was taking the inverse of sine. We get 159.7, which is interesting because that is the complementary part to, or supplementary part to 20.3 degrees. And this one makes more sense. It's in the general area of the other forces. So we're going to go with 159.7. Great.